This is China's great central coastal metropolis, Shanghai. As night falls, a host of lights power on to illuminate its streets, bridges, and buildings. An uninterrupted power supply makes the city seem as bright as daylight. Seen from space, it stands out on the eastern coast of Asia. 400 kilometers to the northwest lies the Har Erwusu mine of Inner Mongolia. There in a giant pit, the air is filled with the roar of a steel colossus. The excavator here can fill 2 wagons with a single scoop, enabling it to dig out 30 million tons of coal every year. That's enough to generate 90 billion kilowatt hours of power, the entire yearly consumption of urban Beijing. With a 75 cubic meter scooping bucket, the machine is the largest of its kind in the world. While the giant excavator is working tirelessly through the night. When 300 kilometers to the south in central China's Changsha, Hunan province, another giant machine is hard at work. The bustle of the daytime city has faded into shadow, leaving the banks of the Xiangjiang River silent. Residents are unaware that right under their feet, a mechanical mole is digging around the clock. This large diameter, slow shield tunnel boring machine weighs 3,000 tons and generates 12,000 tons of crushing force, enough to pulverize any rock in front of it. Carving a tunnel, removing debris, and reinforcing the structure, the mighty dragon forges a path, leaving a finished tunnel in its wake. With machines like this, China was on track to build 6,000 kilometers of subway lines by 2020, making it the fastest metro builder in the world by far. This is large tunneling equipment independently developed by China. The large diameter slurry shield tunnel boring machine. Moving on again 400 kilometers north brings us to Yichang and Hubei province. This is the site of the world's largest hydroelectric project, the Three Gorges Dam, which spans Asia's longest river, the Yangtze. On one side of the dam, an amazing weightlifting show is in progress. The world's largest full-balanced vertical hoist ship lift is hauling a vessel across the dam. It's capable of elevating a 3,000-ton boat 113 meters, the height of a 40-story building. Lifting at a speed of 12 meters per minute, it can send a ship across to the river's upper reaches in just 37 minutes. This is called Three Gorges Dam shiplift. Among these 3 giant machines, one dominates a mine, another boss underground tunnels, and the third hoist enormous vessels. They serve 3 different purposes, but they share one important thing. They were all made in China. Har Erwusu, meaning a place with lakes in Mongolian, is the largest open-pit coal mine in Asia. Seen from the sky, there's no lake here. But there is an abundance of black gold. The mine is rich in quality coal, with a 20-meter thick seam. China is industrializing fast, and coal is the chief source of energy powering its economic engine. To best exploit the resources here, Chinese engineers have developed a mining excavator with the largest bucket scoop in the world. The birthplace of the giant lies 300 kilometers south of the mine. In Taiyuan, capital of Shaanxi Province, China's traditional mining heartland. At the birth of the People's Republic of China in 1949, the lack of domestic mining equipment meant that the country's vast coal resources were left unexploited. It was not until 1961 that a breakthrough 4 cubic meter excavator was developed. A 10 cubic meter machine followed. Then came excavators of 20 and 35 cubic meters in capacity. Finally, the year 2016 saw the arrival of the biggest machine of all, a 75 cubic meter mining excavator. 2,000 tons in weight, 37.5 meters long, 17.3 meters wide, and 23.5 meters high. The machine has a boom able to reach the top of an 8-story building. It rests on tracks that drive it to and fro. The bucket scoop has moved upwards and downwards by the coordinated motion of its arm and boom. Through the movement of a swiveling base, the excavator can turn in a full circle of 360 degrees. If making larger machines was simply a matter of scaling up, then the weight of this biggest excavator would be 18 times that of the early 4 cubic meter excavator, or 5,600 tons, that make it too heavy to move an inch. In reality, however, it weighs only 2,000 tons, a fraction of what was supposed. For machinery, a lighter structure means greater efficiency. Efficiency, performance, and the highest load to material ratio are the targets of Chinese mega equipment makers, from design to development, and on to manufacturing the assembly. Tens of thousands of parts and control lines must all be managed methodically and meticulously. The whole process involves 8 strict stages performed over 700 days. The first step is to cut 11-centimeter alloy steel plates into the required shapes. A cutting machine operator uses a focused propane flame to do this silently and precisely. Every movement must be exact, without even the slightest error. Guided by computer numerical control, or CNC system, the cutter's economy of movement makes it like an experienced tailor working with cloth. Complex optimizing calculations are required to ensure as little material as possible is wasted. Compared to the process of cutting, welding the still sections together is a noisier and lively affair. To make the largest bucket scoop in the world, Pieces of varying thicknesses must be assembled exactly according to design, and pieces of varying strength must be connected according to different strength requirements of different parts, which poses a serious challenge. The bucket scoop could deform or crack because of huge stress is generated at welding points due to differing factors of thermal expansion. Every point must be welded in strict order according to procedure. Hidden by their masks, the sweating faces of welders were expressions of intense concentration. The CNC gantry milling planer, 9 meters high and 6 meters wide, is processing the chassis beam of the excavator. With a weight of 138 tons, enormous size and complicated surfaces, the chassis beam nonetheless has extremely high machining requirements. Only a well-machined chassis will be sturdy and stable enough for the excavator to work for long, uninterrupted stints. The gantry milling planer, as enormous size belies the accuracy with which it compositioned the chassis, and the precision with which its CNC machine tools are brought to bear. Slowly and methodically, the chassis cut, bored, ground, reamed, and polished.
Without this machining platform, this excavator could never be made. It's the working machine, and I'm its doctor. I need to make sure that it can make qualified products at any time.
Of course, factory machines can't work entirely on their own, no matter how automated they are. Credit should also be given to the workshop's dedicated technicians. One of them is the 62-year-old senior technician, Zhang Dongyuan. He has worked at the plant for 39 years and has written work notes running to millions of words in his spare time.
As a maintainer, I have kept all my work logs and error logs non-stop over the last 39 years, including weekends.
Although he has received numerous honors and prizes, Zhang remains a humble man and is devoted to his daily work. A metro system is not only the best way to get around in a 21st century metropolis, it's also a must for any densely built modern city. 49 years ago, China opened its first MRT line, Beijing Subway Line 1. It was built using the open-cut trench method and took 10 years to finish, even though it was only 23 kilometers long. Continuing at such a speed, the capital's entire system, the biggest in the world today, would have taken well over 100 years. Instead, it only took China a little more than 2 decades to build most of the subway lines. It now has in 40 cities more than 6,000 kilometers in length. This engineering miracle was achieved in large part using machines like this large diameter shield tunneling machine, 3,000 tons heavy, 100 meters long, and as high as a 4-story building. At its front is a cutter ahead for digging, followed by a cylindrical shield to prevent collapse. Behind these, there is a backup section for transporting excavated macadam backwards and out, and lining the new tunnel with concrete panels while the whole machine moves forward. One such machine on its own can excavate a twin tracks double direction tunnel For a piece of mega equipment of such size and complexity, manufacturing requirements are naturally tough. To begin with, a 14-centimeter thick steel plate needs to be rolled up using an ultra-large rounding machine tool. As is known to all, the larger the radius of the curve, the harder it is to keep to a perfect circle. To roll up the thick steel plate into a huge circle with a diameter of 30 meters are preventing deformation from gravity. Workers must use a special ruler to check it at short intervals so that every inch of the roll steel plate has the exact same curvature. Next, 4 robots. Weld on both sides of the shield simultaneously to reduce deformation from stress difference. The cutter head is the main component, so experienced welders are also required to build up the welding interface too, as thick as 8 millimeters with wear-resistant materials to form a protective cover. It is only after hundreds of hours of cutting and grinding to a tolerance of 0, 8 millimeters and 24 assembly procedures over 4 to 8 months, that such a circle can be made.
The shield machine is one of the most difficult pieces of construction equipment to make. It incorporates mechanics, electrical engineering, hydraulic pressure, automation, information technology, and optics. Once a problem occurs in a tunnel, the machine can't be retracted directly. We can only dig a hole from under the machine and take it out. The loss will be huge.
The cutter head is the most important catching part of a shield machine. When the machine is working, every cutter rotates just as planets revolve on their own axes while circling the sun. The rotation of the cutter head generates stress to cut and grind. With 12,000 tons of force generated, it can crush the hardest rock. This is the working principle of the shield machine. At a closer look, differently designed cutter heads resemble human faces, with some relaxed and others of more serious expression. The different layouts feature a diversity of cutter types and galley-shaped cutter seats to house them. China has a huge landmass and more geological variety than almost any other nation. Naturally, the shield machine needs to bore through all kinds of rock. To this end, the developers have designed different cutter heads into which different cutter designs can be installed in different combinations to deal with different rock conditions. If a cutter head meets hard rock, for example, cutters called hubs are fitted. The soft rock cutters called slices are needed. And if it's clay, then it's time to use so-called shell cutters. So the garlic-shaped cutter seats are actually for discharging macadam backwards into the outlet pipeline. When the machine is digging through clay, its cutter head needs larger galleys to discharge the sticky earth smoothly if it's up against hard rock. Smaller galleys are enough as the rocks have been finely pulverized. It is in this way that the tens of thousands of tons of macadam generated from each excavation are discharged and carried out of the tunnel customizable cutter heads are the key to working with ever-changing rock types. When fitted with them, the shield machine can be quickly adapted. Of course, there are other features that enable it to work smoothly. This is not a routine cleaning, but a test. When the shield machine is digging in clay, the most serious problem is cutter head obstruction, meaning that mud lodges on the surface of the cutter head and clogs up its galleys so that it can't be discharged smoothly. It is as if the machine were having an intestinal obstruction. This is where nozzles in the cutter head come into play. By spraying a special fluid into the clay, its viscosity can be reduced and its fluidity increased. The problem of clogged up cutter heads is solved. At 7 o'clock, the Three Gorges Cruise number 5 arrives at the Three Gorges Dam and sends a request to the control center of the ship lift. The dam has the world's largest installed hydroelectric capacity and an unmatched water level head of 3.5.4 hours in the ship lift. However, only 37 minutes is needed to cross over. The Three Gorges ship lift has a tower height of 146 meters. It is driven by 4 groups of 8 powerful motors, with 240 counterblocks in 16 groups, connected to 256 74mm steel ropes. It will elevate this Yangtze cruise liner by 113 meters at a speed of 12 meters per minute. When the idea of a ship elevator for the Three Gorges Dam was first put forward, the sheer height of the structure seemed to pose an insurmountable problem. In general, there are 2 mechanisms that can power ship lift: a winch mechanism or a gear rack. After comparisons and discussions, the designers chose the gear rack mechanism for its superior safety. Safety indeed was their highest priority. So through its gear rack mechanism, the chamber carrying the ship is raised through the meshing of gear wheels, symmetrical installed on both sides of the chamber, and racks on the columns of the ship lift. This ship lift is unmatched in scale by any other of its kind in the world. When the ship enters its giant chamber, its electrical drive system must ensure that the lifting speed of all 4 of its drive points is the same, with a maximum error of less than 2 millimeters. That's roughly the thickness of a coin. It is electrical synchronization scheme.
This is a world-class project involving many fields and complicated interfaces. It took an enormous effort in every step of the way.
Each of the 4 gear wheels driving the lift meshes with its own rack of 125 meters in length. What the racks should be made of, and how to make them, pose a unique challenge to the project's Chinese engineers. The engineers conducted many experiments. In the end, they settled on a hardened steel design with a depth of 6 millimeters and a modulus of 62 7 millimeters. For manufacture, each 125-meter rack was split into 25 strips to be made separately and then joined together. With the length of 4.7 meters, the difficulty of making each track segment was unprecedented. Smelting, casting, heat treating, induction quenching, and machine processing. Each procedure had to be executed to the very highest standards.
With lubrication, the lifespan of the structure is 70 years, and the gears and racks 35 years.
After 3 years of development under extreme conditions and 420,000 fatigue trials, the ship lift's rack system, the maximum lifting weight of which is 15,500 tons, was finally created. Thousands of kilometers to the north, workers are changing shifts at the Hairwusu mine. Lu Hongshui starts his day's work. Graduating from the Inner Mongolia University of Science and Technology as a major of Mach electronics, 7 years ago, he's an operator of the only 75 cubic meter excavator in the world. The machine can fill up a 360-ton dump truck with just 3 or 4 scoops. So a line of dump trucks are always lining up. Enormous and powerful as it is also quite nimble in shifting to and fro, up and down slopes and turning. It moves as quickly as a human walks. And it automatically avoids barriers like hard rocks when excavating. How is this achieved? As the head of the team that developed the excavator is Wang Xiaoming. Thanks to his design, the machine's operator can monitor and control its working state via sensors installed on its drive system, elevation system, and thrusting system. Additionally, the development team has endowed it with another smart function. When the excavator's bucket scoop meets hard objects, sensors ensure it is automatically retracted or lifted.
When a man digs up something, he thinks about things like where he should stand and what kind of stuff he wants. And if there is a hard object, like a brick or a rock, they'll try to avoid it. This is also true for the excavator, which is able to think and retract or lift its bucket with the help of sensors.
The engine needs to be operating at a high speed. To lift and rotate the bucket fully loaded with 135 tons of all through 180 degrees. As this is happening, the shaking intensity of the boom can reach 7,900 meters per second, over 20 times the speed of sound, which could break apart the whole excavator. Lu Hongshui, meanwhile, is sitting inside the cab, a few meters away from the bucket. Why hasn't the shaking become intense enough to throw him out of the cab yet?
It took us more than 10 years to conduct the simulation and analysis on the motion trajectory of the bucket, including its moving angles when carrying a load. In the end, we determined a fairly reasonable excavating load spectrum and trajectory.
Tremor is an inevitable problem for any large machine, not least for a machine task with lifting loads of 135 tons. The causes of tremor might include inadequate assembly precision while the running in of a new engine. To prevent the problem, every manufacturing step, from steel plate cutting to bucket welding, from part cutting to assembly, and from optimizing configuration to installing hydraulic drive technology, must be meticulously executed. Such quality control is the only way that tremor can be minimized. To put it another way, making the giant machine must be approached with the same care as doing needlework. The cab Lu Hongshui sits in is the control center of the excavator. Thanks to the complete dedication of the machine's developing engineers, he is able to work in an environment of steady comfort. That way he can sense subtle changes in the bucket scoop's load via sensors installed at key positions, and adjust the operational settings of the excavator accordingly. From Inner Mongolia to Changde in Hunan province, over 1,000 kilometers to the south, Changde-Chenjiang River Tunnel is under construction. Today, the Yuan and Shield machine doing the job is changing cutters. Just like guns and teeth. When its cutter head and cutters are appropriately chosen, it can easily chew through the rock in front of it. But unsurprisingly, cutters wear out more quickly than other components. They must be changed after the machine has moved forward 200 meters or so. The process takes 10 hours to 4 days to complete. As is known to all, earth and water pressure increases with depth at a rate of about 1 standard atmosphere every 10 meters. When the shield machine is working at a depth of 40 to 50 meters, the cutter head and shield behind it must withstand pressure, amounting to 4 to 5 standard atmospheres. To make changing cutters possible, an airtight section is normally installed behind them, with the pressure inside it in balance with the surrounding Earth. When the cutters were out, the technicians changing them have to enter the high-pressure working section and do the job manually. Human cannot work under high pressure. Before they can do so, however, they need to stay in a transition chamber of increasing pressure for 4 hours to climatize the high pressure they will work under. When the pressure in the transition chamber reaches the same level as the high pressure section, the cutter changes are ready. After the job is done, they must return to the transition chamber. And as the pressure inside is slowly lowered, remain there for another 4 hours. Now it's time to change the cutters. These technicians, however, do not look particularly strong or muscular as might be supposed. Even more surprisingly, they don't bother to spend time in any pressure chamber or take additional protective measures. They just enter the chamber directly and begin to change cutters, which is very worrying. The pressure underground will be 3 to 5 times higher than that above ground. It's like putting a grand piano on a cardboard box. How would the cutter changers withstand the high pressure?
We designed a cutter head, allowing normal pressure operation.
In the past, we had people go to the working face and change cutters under high pressure. But now we adjust the pressure there to the normal state and then send people in.
So now they are working under normal pressure. This reduces safety risks and saves time.
Yuanan is one of the first large shield machines in China adopting technology of changing cutters under normal pressure. When cutters wear out, they are automatically pushed to the back of the cutter ahead so that technicians can change them in a normal pressure cabin with high precision vapor liquid equilibrium, balance control technology. Back on the Great Yangtze River, the show of the shiplift is still going on. Although impressive, the machines, gear, and rack mechanism alone cannot guarantee its smooth operation. What if the lift chamber leaks, or its electrical motors fail, or there's an earthquake? Have the designers planned for every possible contingency? 8 electrical motors in 4 groups drive the shiplift, with 16 groups of counterweight police working at the same time. Synchronizing shaft at the bottom operates at a speed of 248 revolutions per minute. All the parts of the shiplift are working steadily, with one exception, hidden inside the pharaohs of the columns. So what's going on? Including the water inside, which is 3.5 meters deep, the shiplifting chamber weighs 15,500 tons. After vessel enters it, the chamber discharges water, equal to the vessel's weight, as would be predicted by our Archimedes principle. Then the chamber rises to bring the vessel across the dam. The chamber is like a giant tray filled with water. 132 meters long and 23 meters wide. If it tilts the water in, it will shift to one end. The other end will then rise because it is lighter. Then the tray will lose balance. This is called plate effect.
The biggest technical problem is to keep its balance while it operates, so that there are no shakes, and those aboard vessels feel stable.
So, how to overcome plate effect and ensure smooth operation? The secret lies within furrows in the columns. These are screw arbors and nut columns mounted on the chamber columns. When the chamber rises or falls, short screw arbors inside turn without touching the nut columns that house them. There is a 60-millimeter gap between the screw threads of the nut columns and the screw arbors. If the chamber starts to tilt, the gap between the screw-ups and the nut columns gradually disappears until they interlock and the system stops working automatically.
It was the first to use a gear rack lifting mechanism.
Thanks to its 2-millimeter precision of lifting, the Three Gorges ship lift can operate as steadily as if the chamber were resting on flat ground. Supported by 4 groups of engines, it can still work. Even if any 2 of them fail simultaneously. Thanks to counterweight blocks with the same weight as the chamber, it only needs a driving force of less than 2.5% of the total weight. Its ever-reliable system of screw arbors and nut columns gives it an unparalleled degree of safety. That's how it stays away from the plate effect. In the Herwusu mine, meanwhile, the 75 cubic meter excavator is working day and night. The coal exhibits every year can support about 2% of China's total power generating capacity. Giant as it is, however, its position as the biggest of its kind is being challenged. An even larger and more advanced mining excavator is under development in Taiwan, in central China.
I've worked on this for my whole life. That's 30 years. Take any one of its tens of thousands of parts, and I can tell you where it belongs and what it's for.
Today, in a dozen countries, including Russia, Peru, Chile, and South Africa, Chinese mining excavators are hard at work. The ingenuity of Chinese engineers is reshaping the landscape of the planet. In Changsha, meanwhile, plants are manufacturing shield machines in full swing. But they are only the tip of a very large iceberg. Over 85% of the subway tunnels in China are excavated by shield machines.
Before 2008, we used shield machines, but from abroad, we know their strengths and weaknesses because we have rich operating experience. So when we were developing our own machines, we took a problem-oriented approach, which has never been taken before.
Nowadays, Chinese-made shield machines have a 90% share of the Chinese market and 2/3 of the global market. In countries participating in the Belt and Road Initiative, Chinese shield machines are lifting up the living standards of locals. Nearly 6,000 ships cross the Three Gorges Dam, and it's shiplift every year. As the final installation in the entire project, the shiplift has reduced the time needed to cross the dam by 5/6 ensuring continued navigation of the upper Yangtze River. From China's 75 cubic meter mining excavator to its large diameter shield tunneling machine and the Three Gorges ship lift. These feats of engineering all dominate in their fields. Beyond their impressive size, their true value stems from the engineering talent of their creators, the product of a long struggle against the obstacles of the physical world. In Chinese labs and workshops, engineers continue with this struggle. The breakthroughs they make will benefit the whole of humanity. In the near future, Chinese mega equipment will be building us all a better world.